Hi, this is Pratyanja from NIT Jamshedpur. Today I am here to give a brief presentation about my PhD work. This is just an introduction about me. I'm going to submit my PhD in next 6 months. These are the contents of my presentation. I will flow in this manner from microwave band to the limitations of narrowband system, what technology we are using, what are the different applications of that. Again, the physical limitations of wideband antennas, what are the objectives we have set, and how will further move with that objectives, my future work, and the publication. So this is basically the electromagnetic spectrum. We are working basically on a microwave band ranging from 300 megahertz to 300 gigahertz. And in this system, microwave band, again, there are the different number of sub bands, which is specifically from L to K band. And now we'll mainly focus on the limitations of narrowband. The first problem with the narrowband system is the limited data rate. We are able to only send a limited data rate by using narrowband system. Also, it is very insecure as interference of the other bands are very high and they are easily detected and jammed. Now, when it comes to the range of operating frequency, the availability of space is a constraint for installation of multi-band antenna. So here, one technology is there, ultra-wideband, and it is having a number of advantage over narrowband system. First, the high data rate is there, the high precision ranging. Also, the cost of development of that particular antenna is very less. So what is basically ultra wideband system? FCC define its range, which is operating from 3.1 to 10.6 gigahertz. Also, if we satisfy this relation where the fractional bandwidth is greater than equal to 0.2, we can say our system is an ultra wideband system. But as and these are the different application of ultra wideband system in the area of radar, in the area of communication, intelligent sensor, nowadays medical applications. Now, every system has a disadvantage. What are the different disadvantage of wideband antenna is, the first part is the front to back ratio is very high. And the second one, which is very challenging, that the gain is not constant over the complete band, which is from 3.1 to 10.6 gigahertz. Or if we design a wideband system, which is more than 10.6 gigahertz. So we set our objective on the basis of disadvantage of ultra wideband system. That the first is we have to design a complete wideband system which not only covers the range of ultra wideband, also it covers up to the K band, which is nearly 18 gigahertz. Our second challenge was we have to choose that substrate which is easily available in the market for the research purpose. So we use FR4 here as a substrate here. And the third is because we have to focus on our objective that our gain should be constant. As in the wideband system, the gain is not constant over the complete band. So for that, we have to design one layer which transmit all its energy into one single direction when it is in phase. So these are the different objectives. So to satisfy the first objective, our first part is compact high gain key-shaped monopole antenna. Now this is our proposed design. We have achieved this design in 6 iterations. This is the fabricated model, and in this comparative analysis, we can see that our design is very compact. Its range is 2.95 to 19.15. The fractional bandwidth is 146%, and yes, we are using an FR4. Also, we have realized this proposed antenna using circuit modeling. So this is the circuit modeling we have done for that particular antenna. And yes, we have mentioned about the gain that at higher frequency from 16 to 20 gigahertz. The gain is comparatively high as compared to the lower frequency. So the first part is we have achieved is we attain a wideband. Yes, there is a gain at high particular frequency. So now next objective is to design something which transmits its all energy into one direction, and further we improve the gain. So for that we use an FSS. This is just an historical overview about FSS. So we designed this FSS layer with ultra wideband range and angular stability. for this is the unit cell, and in comparative analysis, you can see that our design is very compact. The size is almost 5.5 or 5.5 mm. The substrate thickness also plays an important role in the achieving the wide bandwidth. So our substrate thickness is 0.8, which is very thin, and it covers the range of 2.84 to 20 gigahertz. And we have achieved this design by using 4 iterations. We have also covered this design by using equivalent circuit modeling. This is the circuit equivalent circuit of that particular design. And also we have measured and simulated plot of shielding effectiveness for TE polarization and TM polarization. This is the final FSS structure. So for future work, now we have complete wideband. Now we have one layer. So when we placed layer with antenna, definitely we can improve the gain. So this is our future work. We have to observe that up to where we can improve the gain and the directivity. Also, we are working for a multi-band FSS so that we can generate for a system which is having some specific band to be passed and some specific bands which has to be blocked. So these are all my future work. This is my publication for SCI Journal and different conferences I have covered. Thank you for listening me, and I hope if I get the chance to explain my work in detail there, so definitely I will justify the opportunity. Thank you. Thank you for listening.